then the side length would be that times rad 2 divided by 2.
Mm-hmm.
Then you would leave it like that.
Yeah. Well, I mean, unless you could reduce it. Like if that's an even number, if it was...
Well, yeah, because even you divide by 2 and then it's that times rad 2. But
right.
if it's just odd, then you would leave it like that.
Yes. Is that what you said? Odd? Sorry, I missed the odd part. Okay. Let's see. Number 10. So just remember, your sides are L, L, and L rad 2. So if 15 rad 2 is your L rad 2 side, what is L? 15, right? L is the 15. So that means this side is 15 and this side is 15. Okay? Number 10. Number 13. It says you have the side length of the smallest square plate on which a 20 centimeter chopstick can fit along the diagonal. Okay, so a square plate. I used to have square plate. They were square plates. They were awesome. Loved them. I don't anymore. They were all chipping, but I mean, I got them as a wedding gift, and I've been married for 16 years? I should know that. I think it's 16 years. Sorry, babe. Yeah, so they started chipping. I got new ones. They're not as cute, but they do the job. So if you put a chopstick diagonally across the square, you have 20 centimeters here. Because it's a square, these would all be right angles, and that chopstick would cut that right angle in half, so 45 and 45. So we need to know that length. What is the side length of the square? How do you do that?
Don't you like divide 20 by 2, then it would be 10 rad 2, but since it's like a word problem, you do 10 times rad 2.
You could teach the class, guys. So take that length, right? That's your L rad 2 side. Now, if you don't like the shortcut to the shortcut, right? Here's your other option. 20 is your L rad 2 side. So I'm going to just show you one more time how you can solve this, just for those of you that don't like to do the shortcut. Divide by rad 2, and then multiply by rad 2 over rad 2. So it's 20 rad 2 on top, right? That's what this is. Rad 2 times rad 2 is the square root of 4, which is 2. Then simplify that. So that's 10 rad 2. But like Whitney said, we don't love radicals in real world problems because nobody really talks like that. So plug that into your calculator, 10 rad 2, and you will get something, I don't know what, 14.1, nearest tenth of a centimeter, so 14.1 centimeters. Okay. 14 is pretty much doing a similar thing. It says the 4 blades of a helicopter meet at right angles and are all the same length. So basically you have something like this where they all meet at right angles. If I connect all these endpoints right now, what shape do I get? It is going to be a square. It has to be a rhombus, right? Diagonals are perpendicular and the distances are the same. But yes, with all the things that require it, it would be a square. So it says the distance between the tips of 2 adjacent blades, in other words, this length right here is 36. How long is each blade? So what is this length and this length? Well, this gave us a 45, 45, 90. So if this side is 36, then what is this side? Cut it in half, multiply by rad 2, and then just plug that into your calculator. 18 times the square root of 2 is something, 25.5 feet. Okay?
Do we always round to the nearest tenth?
Typically it's nearest tenth, but yeah, you kind of just pay attention to what they tell you to round to. Okay, 27 and 28, I would say, are probably the harder ones because I intentionally did not show you how to do them because I wanted to see how forward thinking you would be. So you see this and you go, I have no idea, right? Which is fine. I want you to challenge your brain a bit. So what I would do, what you should do in this situation is if I draw that line right there, I just made for myself a 45, 45, 90 triangle. Do you see it? 45, 45, 90. Okay, if that's the case, what is this length?
3.
It's 3. If this side, your hypotenuse, is 3 rad 2, then this is 3. What is this length?
3.
Also 3. So you have, for your A, it's 3. For your B, it's how long?
7.
7. The 4 and the 3 put together. So B is 7. Okay. 28. If you draw that line in, here's your 45, 45, 90. What's the length of the leg in the 45, 45, 90? 6. So if this is 6, then this is 6, then this is 6 rad 2. Oh, who's calling? What would A be?
Would be
14, right. So this length is the whole thing. This piece of it up here is 8. So 8 and 6, add those together, you get 14. Okay? So if you see an angle measure like a 45 or in tonight's homework, a 60, this one's got a 45 and a 60, a 30. We're going to do 30, 60, 90s tonight. Keep that in mind. Maybe like right here, for instance. Okay. Last one. This one just says a right triangle. Any old right triangle has a 6-inch hypotenuse and a 5-inch leg. Find the length of the other leg in simplest radical form. We know nothing about the shape of this triangle other than we know this is 6 and this is 5. And I think a lot of you, because you were in 45, 45, 90 mode, thought it's got to be a 45, 45, 90. But they didn't say that. They just said a right triangle. So how do you find the third side of a right triangle?
X squared plus 5 squared.
Yeah, Pythagorean theorem. X squared plus 5 squared equals 6 squared. So 36 minus 25, I'm going to move down here. So x squared equals 11 when you subtract that. And then we take the square root, and that you can't break down into a perfect square and a not perfect square. So you just leave it, x is the square root of 11. Okay? Good on that? Okay. So for 8.2b, we are doing 30, 60, 90 triangles. And again, just like the 45, 45, 90, those represent what in the triangle? 45, 45, and 90. 30, 60, and 90. Those are what in a triangle? What? They're angle measurements, yeah. So we're looking at a triangle that has 3 different angle measurements. One is 30 degrees, one is 60 degrees, one is 90 degrees, okay? So a 30, 60, 90 triangle, when I talk about a 30, 60, 90, that's what I'm talking about. A triangle that has a 30-degree angle here, a 60-degree angle here, a 90-degree angle here, okay? Here's what the 30, 60, 90 triangle setup is. Your hypotenuse is probably your easier of the two sides. Your shorter leg, we're still gonna call L, okay? So we're gonna think of that in terms of, we're gonna think of everything in terms of L. So your shorter leg is your L, okay? But then everything's in relationship to that shorter leg. So if that's L, then the hypotenuse, lovely enough, is just double that, okay? So it's 2 times the shorter leg. So we're gonna call this 2L. And then the longer leg is a little more like the hypotenuse of the 45, 45, 90, but instead of multiplying by rad 2, we multiply by rad 3. Okay, so just if you're gonna struggle to keep straight which one is with which, just remember this 3 goes with the 30, 60, 90 triangle. The rad 2 goes with the 45, 45, 90. Okay, so 3 with the 30. So what that looks like here, this is going to be the length of the leg times the square root of 3. Okay, so this is your general setup for a 30, 60, 90 triangle. And just like I said yesterday, if I were you, I would take a little screenshot of that setup and I would drag it with me through the homework so that you have it handy, so that you're getting really used to what sides are what. Take it with you wherever you go, and it will just be ingrained a whole lot quicker. Okay, this part. I'm just going to show you why this works. Don't feel like you need to write this down right now. In fact, I would probably encourage you not to. I want you just to understand what I'm saying. And if you're madly writing what I'm writing, I feel like sometimes it just doesn't sink in as well. I will never ask you to do this for me on a quiz or a test. I just want you to see how these brilliant mathematicians come up with something so brilliant. Okay, here it is. This is an equilateral triangle. Okay, so those are all congruent sides. If I draw that line in, do you remember what we call that line? Starts with an A. The altitude. Okay, so if I draw that altitude in right now, first of all, we know in an equilateral triangle, every angle is 60, right? So when I draw that in, it bisects up here to get us 30 and 30, okay? Now let's say the length of all our sides is 2x. Then what is this length? X. Okay, now we have this right triangle here. And with a right triangle, you can use what theorem to find a missing side? The Pythagorean theorem. So I could right now say x squared plus, let's say we just call this y, just for a different variable. X squared plus y squared equals 2x squared. Well, if I simplify that, that looked funny. This would be x squared plus y squared equals 4, because we've got to square the 2, x squared, right? Take away an x squared, and I get y squared equals 3x squared. Well, I want to know what y is. I want to know what this side of that triangle would be, or the height of the big triangle would be. The way I do that is I square root both of these. Well, when I square root y, when I square root y squared, I get y. The square root of 3, we can't do anything with, but the square root of x squared is just x. So this side right here would be x rad 3. So think of it, replace it with an L, right? L rad 3, and 2L. That's how they came up with it. Very simple, the Pythagorean theorem, okay? So again, if you're ever stuck, you can use the Pythagorean theorem on a lot of these types of problems. Yeah?
How did you get the 3 out of the 4?
When I subtracted the x squared over here, when I took x squared away, it was a 4x squared. So I took away 1x squared, and 4 minus 1 would be 3x squared then. That makes sense? Yeah? Okay, so let's try some of these. The idea is very similar to what we did yesterday, but you have to know which side you're working with, okay? So here's what I want you to see. Notice my 30-degree angle is right here right now. Across from my 30-degree angle is my shorter leg, okay? Look up here. Across from the 30 is my L. That's my shorter leg, right? Across from the 60 is the longer leg, which is going to be your L rad 3. And then across from the right angle is your hypotenuse. So just make sure you're keeping straight. It's not like the bottom one is always my L. L is always across from 30. So in this picture, this right now, 5, is representing my L. Okay, this is my L side. Can anyone tell me the length of y? 10, yes. I don't know if I've said this in here. I'm not a hand-raising teacher. Just speak to me. Like, I don't mind if you just shout out numbers. That's great. I'm not trying to be rude by not, like, calling on you if you raise your hand. I would rather just have a conversation. So feel free to just shout numbers out at me. So if this is 5, right, this is the 2L side. And because L is 5, 2 times 5 is 10. Okay, so that's 10. What is X? 5 5 times the square root of 3, right? The side across from the 60, so here's 60. The side across from 60 is L rad 3, and because L is 5, 5 rad 3 will be your x. Okay? Questions on that? Okay. Example 2. This is probably the most difficult setup with a 30, 60, 90, is when they give you this side. Notice it's the side across from the 60 as a whole number. Okay, because normally that side is our what side? L rad 3. So this is our L rad 3 side, but it's equal to a whole number. So what happens is we do what we did yesterday, pre-shortcut, okay? And then I'll see if you guys can figure out what the shortcut is on this one, because their shortcut to the shortcut still exists, but it's different in a 30, 60, 90. So bear with me for a second. The first thing I'm going to show you is how you would solve it the shortcut way, and then we'll see if you can see the shortcut to the shortcut. If I know 15 is L rad 3, how would I solve for L?
You would divide by rad 3.
Divide by rad 3 on both sides. Okay, now we have to rationalize our denominator. You can't leave a radical in the denominator. What do I multiply by? Rad 3 over rad 3, right? We want to multiply by 1, so rad 3 over rad 3. So I have 15 rad 3 in the numerator. What's my denominator?
3.
It's the square root of 9, which is 3, right? So rad 3 times rad 3 is rad 9, which is 3. What does that simplify to? 5 rad 3. Okay, now look at this. That's this side. This is our L side, right? The shortest leg is our our L rad 3 side. So H is 5 rad 3. Okay, what is G? It's 10 rad 3. This is your 2L side. So you take this and you multiply it by 2, which is 10 rad 3. Okay, now look. We started with a whole number on our L rad 3 side. 15 turned into 5 rad 3. Shortcut to the shortcut?
Divide by 3 and then the middle not 3 goes on the outside.
Right, so remember yesterday it was multiply by rad 2 and divide by 2? Now it's multiply by rad 3 and divide by 3. The issue is far less numbers are divisible by 3 than were divisible by 2, right? Now it's not an even odd thing anymore. It's, is it divisible by 3? So if you end up with 17 right here, you would do what we did yesterday. 17 times the square root of 3 divided by 3 every time, okay? If it was 18, then it would be 18 times rad 3 divided by 3, and that would simplify, right? Because that one is divisible by 3. Again, that's the shortcut to the shortcut. You don't have to do it that way. You may do the math and solve it every single time, okay? Totally up to you. Okay, questions thus far? And this stuff's so fun, you guys. I love this chapter. I love it. Love it, love it. Okay, example 3 is probably one of the easier setups for this. Notice which sides we have. Across from the 30, so this is your shorter leg. Across from the 60, this is your longer leg. 16 is your hypotenuse. Can anyone tell me A?
8.
It is 8. Because this side represents 2L, right? So if 16 is 2L, you got to cut that in half. That means A is going to be 8. So what is B?
8 rad 3.
8 rad 3. Okay. Give you a second to process that. Oh, I picked the number I gave you on the question. That was dumb. That's okay. Okay, look at example 4 here. Actually, no. I'm going to change it because I already did 18 with you. scribble that out. Call it Call it 24. Okay, so if this is my setup, can anyone tell me what y should be? 8 rad 3. You take the number that is across from the 60, right? That's your longer leg. You divide by 3, and you multiply by rad 3. So that's 8 rad 3. I'm going to show you one more time the longer way to solve it, okay? I know that 24 is my L rad 3 side, okay? If you're going to do the shortcut to the shortcut, you don't even have to write this down. But for those of you that need to like do the math to get there, here's the math. Your first step to get L by itself would be divide by rad 3. Okay, so this is gone. Now to get that radical out of the denominator, multiply by rad 3 over rad 3. So on top, you have 24 rad 3. On bottom, what's rad 3 times rad 3? It's 3, rad 9, right? Square root of 9 is 3. And then simplify that, 24 over 3 is 8. 8 rad 3 is this side then. Okay, that's your L, right?
So if it can be divisible by 3, then you can just take 24 divided by 3, and then whatever you get times rad 3.
Mhm.
And if it's like harder, then you do it that way. Like if it doesn't divide by 3.
If it doesn't divide by 3, you still don't have to do the math for me if you know the shortcut. So like say it was 26, right? If I had a triangle and this was 26 and this is my, 60 up here, then I know this side is 26 times rad 3 divided by 3. There's nothing I can simplify about it. So you would just write it like that.
So that would be the answer.
And then if you had to do the hypotenuse on that one, you're doubling. So 26 times 2 is 52 times rad 3 divided by 3.
So the only thing that would change was the 26 times 2. Then you still leave like the rad 3 divided by 3.
Yeah. Okay, last thing on this one. If y is 8 rad 3, this side is 24, what is my x side? 16 rad 3, right? You're just doubling your shorter leg. So 2 times 8 rad 3 is 16 rad 3. Good on that? That's the 36.